Let's graph some linear inequalities. So, as with solving inequalities being very similar to solving equations, you're going to see that graphing them is also very similar to the way we graph equations. So, let's start in our standard y equals mx plus b form, but instead of an equal sign, we have an inequality sign. Less than or equal to. But for now, we're just going to ignore that and graph this as we would an equation. So we started our y-intercept of -1, and we're going to go up 1 to the right 2. That is our slope of 1/2. Just like that, and draw the line. And now that we've done that, we take into account what this inequality sign means. So let's just think about it. If we are looking for points that are less than this line, which is what it's saying, then are we going to be looking above the line or below the line? We are going to be looking below the line because it's less than. So we're going to shade the area below the line, like that. If you've ever learned about having to test points and plug in coordinate points on somewhere on the graph to figure out if the inequality is true and all that stuff, that's really not necessary. This method of just looking at less than being under the line and greater than above the line works every time. The testing points is really overcomplicated for no reason. And if you have no idea what I'm talking about, well then, good, because you really don't have to learn how to test points. So I think you can see how we're going to do this one already. We have a y-intercept of -3, slope will be 3 and -4, up 3, x changes by -4, there we go. And this time we have a greater than sign, which means we will be shading above the line. So that is really the only new thing with inequalities, is that you have to shade on one side or the other. Except for one other little thing, which I will show you now. If you have this. So what's different about this one is that since we have a greater than but not equal to, we're going to draw the line a bit different. Since it cannot be equal to any point on the line, we're going to draw a dashed line. So we're going to start at a y-intercept of 5, but the line, so we have slope 1, so let's just plot a few points. Let's plot every 4 like that, okay. The line passing through these points will be dashed like that. A dashed line shows that it is not equal to, only greater than. So then we will shade on the greater than side. So that's the only other thing you have to remember. Okay, let's do one more like that. Y is less than -4x. So there's no plus 0 here, but that's essentially what this means. It means we have a y-intercept of 0 and a slope of -4. So up 4 over -1. And since it is less than but not equal to, we will connect these points with a dashed line. Now here it's a little hard to tell which side is less than and which is greater than, but you can kind of tell by the way the line is slanted that this whole area over here is going to be the less than side. It's sort of being pushed down by the line, and this side over here is above the line. Okay, now let's move out of the standard y equals mx plus b form. Now with inequalities, you cannot use intercepts to graph, and you will see why later in this video. But for now, we're going to convert this into y equals mx plus b form. We move the 3x over, and now we're going to divide everything by 6. So here we have fractional y-intercept, negative 3 over 2. So instead of going up 1 over 2, we're going to go up 1/2 over 1 to get back on the grid line. And now we can just follow the standard slope. And since this is less than or equal to, can be equal to a point on the line, we're going to draw a solid line. And now, since it is equal to or less than the line, we're going to shade below the line. Okay, now let me show you in this problem why you cannot use axes intercepts like I showed you in the last video to graph these. Okay, so we want to convert to y equals mx plus b form instead, which means let's get all the y's on the left side. So we'll have negative 2y, bring this y over, it'll be negative 3y is less than negative 5x. We'll bring this over, so it'll be negative 5x plus 3x, which is negative 2x. Now we're going to divide both sides by negative 3. But remember, when you divide an inequality by a negative number, the inequality sign flips. So this changes to greater than 2 over 3x. And this right here explains why you can't use axes intercepts to graph. Because if you do that, then you won't have ended up flipping the inequality sign, and you will end up shading on the wrong side of the graph if you had to divide by a negative. So because this happens in certain occasions when you have to divide by a negative number, graphing by axes intercepts will occasionally be incorrect. So I would just say don't use it. Always convert into y equals mx plus b form when you are graphing inequalities. Okay, so now let's go ahead and graph this. 2/3 x. It would be a plus 0 here. So we start at 0, 0. And we're going to go up 2 over 3, up 2 over 3. And in the other direction, okay. Whoops. Hold on a second. Don't forget this. It is not equal to, so we are using a dashed line. Very easy to forget that, so make sure you pay careful attention to whether or not there is an equal sign here. And we are going to be shading. Greater than means shade above the line. Now let's throw in something interesting. Start with a more complex problem. Okay, so whenever you have parentheses, first thing you want to do is get rid of those by distributing the -6 like that. And now you see we have -3x on both sides. So what that means is when we move the -3x from this side over there, -3x plus 3x is going to be 0. So it'll disappear and we'll be left with y is less than 1. Y is less than 1. There is a horizontal line. We find the line where y is 1, which is this line right there. But before you draw it in, remember that because it is not equal to 1, it is only less than 1, we're going to use a dashed line. And then, because it is less than the line, we're going to shade below it. And here you can very easily tell which side is below the line since it is perfectly horizontal. Okay, and now you know what comes after we do a horizontal line. We look at how a vertical line works. So here we start with 5x here, so let's just divide both sides by 5 and get y is greater than or equal to -4. X is greater than or equal to -4. So x is greater than or equal to -4. X is -4 along this line right there. And since it is greater than or equal to, it is greater than or equal to -4 or equal to means that we can draw a solid line. Now this one works a bit differently because normally greater than just means above the line, shade above the line, and less than means all points below the line. But since this is a vertical line, neither side is really above or below the line. So just think about it. We're talking about points that are greater than -4. So on which side of this line are the x values greater than -4? That's going to be on this side, of course. So you just shade over here. So it all makes sense. And that is it. Graphing any linear inequalities is really not that hard. It's the exact same thing as equations, except for two things you have to remember. You have to remember that greater than means shade above the line, all points above the line, and less than means all points below the line. And you have to remember that when it is not or equal to, just less than or greater than, you used a dashed line instead of a solid line to show that all points on the line are not included.